Unit tests are supposed to help you find bugs. And in some situations, you need a test double or a mock object. And that can be really useful for isolating the unit under test, giving you feedback on your design, which is great. But the test and the test double are still supposed to help you find bugs. The complexity of test code that uses test doubles can sometimes make it harder than you'd like it to be to actually tell what's going on when a test fails, to identify that bug. In this learning hour, we're going to use a spy, and we're going to write some tests that fail. This session is similar to a previous one I did where we used a stub, and we're going to talk more about the difference between those types of test double. I want to help you to continue your team discussion started around how to design unit tests that when they fail, they clearly show you what's wrong and what the bug is. Hi, I'm Emily Bache. I'm a software developer, creator of Saman Coaching. This is a guided learning hour, and based on this video, you can lead this session with your team. You'll need some supporting materials, some code samples, an activity board. You can get the code from GitHub and a copy of the board via my Patreon. Do check that out. It could save you time. Also, if you like this content, please subscribe to my channel and like this video. If you haven't seen one of these guided learning hours before, do take a look at my video, Guided Learning Hour How To. Also, watch to the end of this video because the last part is a session briefing, which is important information for you before you lead this guided learning hour with your team. In a moment, I'll begin the part of the video that you will show your team, and it's marked with the chapter Gather Your Team. So start from there when everyone's ready. Hi, I'm Emily Bache. Today's topic is test design, specifically test doubles, and how they can help you to find bugs. We're using a shared online whiteboard that everyone should have access to. Let's begin with a code review. There's some code on the screen here, and I've highlighted there's a bug in it. So read the code and see if you can work out what the bug is and how you would write a unit test that would fail because of the bug. Well, I don't know what you've been discussing, but I'm hoping that you've all realised that this bug is that of this list of users, the first one on the list is not going to get the notification because of the bug. So we would like to be able to write a unit test where we would give it some users and check that they all, in fact, got the message. But the messages are being sent by this Notifier object, and we don't have the real implementation here, we just have the interface. And the real implementation is making a network call. So hopefully you've noticed that actually we probably can't use the real one in the unit test. So maybe we should replace it with a test double. We had a previous session on test doubles, so if you've done that, this might be a bit familiar, but this one is a little bit slightly different kind of test double. A test double is a piece of code that you use when you've got a unit that you want to test that has a dependency on something else that you need to replace with a test double. Perhaps there's some awkwardness with the real implementation that means that you would like to replace it, or you just want to have a very small unit to test. The name test doubles comes from Jared Massaros, and the basic idea is the same as when you're watching a film, and sometimes when the actor needs to do something really dangerous, the person that you see on the screen is not actually the famous actor, it's another actor who is the stunt double who does the dangerous stuff. But they look almost the same, and as you're watching the film, you don't actually realise that it's not the famous actor. So it's the same with the test double. The class that you're testing doesn't realise that it hasn't been given the real one, but because it's not the real one, you can take more liberties with it and your test has more freedom to test more stuff. So the way it works with this code is that it's the notifier that we want to replace with a test double. And the apply method is going to be completely oblivious to the fact that it's not the real one, but it means that our test has more options. And in this case, it's actually quite easy to do the switch, to replace the real class with the test double, because the discount applier takes this to the constructor. So we just pass a different implementation, one that the test has control over. This is a kind of dependency injection. Okay, so that's the theory. Let's look at a demo. In this demo, I'm tackling the discount applier kata in C#. You may be using a different programming language or environment, but the principles of test design should be essentially the same. Try to focus on the way I expose the bug, designing test cases that make it clear why they fail. So what it wasn't quite clear from the code I showed you already was there's actually two versions of this apply method, and they have slightly different bugs. So the bug that you already looked at is that the first user on the list is not going to get the message. And the second variant of the same method is a similar bug, except that this time it's the first user on the list that gets all the messages. They get really spammed. So we can test both of these bugs in a similar way, but I thought it was interesting to look at. So I made a little start on writing some tests, and these two tests for the two versions are both entirely empty and they pass. And what we're trying to achieve here is tests that fail because of these bugs. So here we need to create the class under test, the discount applier. And of course, that constructor needs to take an argument, which is the notifier. And in this case, we want to have a test double for that. It's an interface. So we can make our own implementation, a test double notifier. So let me create that type. And it already inherits the right interface, which means I can very easily add the interface members that it's lacking. And the default implementation there was an exception, but for the moment I'm going to leave it blank. Okay, so what else do I need here? Well, I'm clearly going to need to call the method that I'm trying to test, and that's going to need a discount, let's say a 20% discount, and we need a list of users. Okay, so let's create a user. And if I do this, then it will help me to create a variable of the right type. And the constructor here needs a name and an email. So I'll hopefully be able to come up with some suitable test data here by hand. Now that's actually part of the arrange part of the test. I'm just moving that up with the rest of the arrange. Okay, so now we need some kind of assertion in this test. So what we want to do is to check that that user got the message. And the way I'm going to do this is I'm going to ask my notifier, well, who is in your notified username field? Is that this user? So that means that this test double is actually going to need to have a field, a new property. Oh, and when I ask it to create that, of course, it thinks I mean to put it on the interface. But no, this is just for the test double, not for the interface. I'm going to back that out. I made a little mistake there. So I need to clearly tell it that actually, no, I'm working here with an object of type test double notifier, not the interface at the moment. So now when I ask it to create that property, it puts it on the right object. So this is going to be a string, the name of the user that I've notified, or at least the one that I notified most recently. So so now in the notify method, I'm just going to store the username that I'm given in this property. Okay, so hopefully that will work and expose the bug. Yes, the test failed. That's what we were looking for. It was expecting user 1, but we got null. This was never set. So that's actually exposing this bug. And if I go and fix the bug, I'm expecting this to pass. Yeah, yes. So this test exposes the bug and it passes when the bug is not there, which is what we were trying to achieve. Okay. So that's great, but let's just look at how to apply the same kind of technique to the other situation where we've got the other bug. Okay, let's just try with the same test. So we're going to call the version 2 of the method with the same logic and so on. Now that passes. So that version of this logic is not going to find that bug. And if you remember what this bug was that we're actually calling this notify on the first user in the list repeatedly. So actually to expose this bug, we're going to need more than one user in the list. So let's create another user. I'll call that user 2. And then I put that in the list as well. And now I need to make sure that user 2 comes up in the notified username. So let's try that. Yes, okay, so this does actually expose the bug. It's showing that the most recently notified user was not user 2, it was user 1. which does, expose the problem, but it's not a very good error message. If I got this, I'd be like, oh, well, what's going on? And I'd probably get my debugger out. And, if I can, I'd like to write a test that will explain so clearly what went wrong that I wouldn't need the debugger. And it's not actually much more work. So let's just look at how I could do that. The basic idea is that instead of only storing the most recently given username, I'm going to have a list and I just append things to it. So every time this method is called, I'm going to append to this list of usernames. And I'm doing this in parallel with the existing functionality in this test double so that I don't break anything that's already working. This is an example of parallel change. Okay, so now I can assert that my list that I'm storing in my notifier, my test double, contains user2. And it should also, of course, contain user1. So let's check for both of those. Now let's run this and see if we get a better error message. Oh, no, of course we didn't, because I've left in the previous assertion. Let's remove that. I'm going to do this instead, actually, in this test. Okay, so we've got, we expected some item to equal user2, but it was user1 and user1. Right, so now this looks to me like I've really exposed this bug. I can see that the list that I was expecting to contain two different users only contains the same user twice. And that hopefully is clear enough that I could go and fix this bug. So in fact, let's go and fix the bug and check that this test passes. Great. So that was also passing when the bug was fixed. So I'm just going to put both the bugs back now because I actually quite like my new version of this test double, which records a list instead of just the most recently called one. So I'm just going to refactor the previous test to use this as well, because I think it just improves the error message a little bit. So this time we can clearly see we didn't get user1 in the list. In fact, the list was empty. So we know we didn't send it to the wrong one or the wrong one twice or something like that. So I think that's a better error message. And then I don't need this field here. So just simplify that code a little bit. Now it's your turn to write some code. I'd like you to do the same as I did and write some tests that will expose both versions of this bug. And if that's all you get to, that's fine. But if you have a little more extra time, you could also write the same tests using a mocking framework. And you should use whichever mocking framework you've used before and works well with your language. But the same principle applies. You're trying to write a test that fails and exposes the bug clearly so you know how to fix it. I hope you've all been successful now writing some tests that fail because of this bug, and you've used a spy. We've got a bit of time now to discuss the theory about this kind of test double. Now, a spy is a kind of test double that records what happens to it so that your test can query it later. It also does everything that a stub might do. So we looked at a stub in a previous session. It's a kind of test double that just returns canned answers that you prepared beforehand. So if it needs to return anything from a method, you've told it what to return. It does the same every time. So a spy might need to do that too, but in addition, it will also record what happens to it. In this exercise then, you've used a spy so that you know which users were notified. So I'm hoping that you can have a bit of a discussion now about how you can use this technique more widely in your code. So how does a test double help you to expose a bug? And if you've used a mocking framework and tried that out, how does it compare with hand coding your own mock or your own spy? Does it make the test easier to read and understand as well as easier to write? Otherwise, what's the point? So have a little discussion about that in your team. Just at the end of the session now, it's your chance to quietly just reflect on what you've learnt and what you think you're going to do next. So answer this question, write a note to your future self. When should you use a test double or a spy or a mocking framework? Take a few moments to collect your thoughts and note them down. I hope your team has had a good session and had a good discussion, and that each person was able to write that short summary at the end with your own ideas about how to use spies. So when you're coding in your production code today, look out for opportunities to write test cases that, if they fail, will point clearly at the reason for that. Happy coding! This is the session briefing. It's intended for the developer or coach who's going to host this guided learning hour. The idea is that you shouldn't need to be a full-time coach to be able to put together one of these sessions for your team. Any developer with a small amount of preparation time and some enthusiasm should be able to fix this. In this particular guided learning hour, there are several points where I ask you to pause the video and lead some activities with your team. There's a connect, an exercise, then a discussion and a brief conclusions. It shows here on the screen roughly how long each activity should take, because part of your job is to keep track and prompt people when it's time for the next thing. In the Connect exercise, I'm asking people to read some code, so do give people time to read it before you start talking. And then, if no one's saying anything for a bit and you think they've had time to read it, you just ask the question again, the same one that I pose. And then, hopefully somebody at some point might say, we need a mock, or a test double, or a stub, or a spy, and that's great. And then you really need to encourage them to explain what that is. Because, in the rest of the video, I'm about to explain what that is, but somebody in your team also explaining it just makes it even better, more opportunities to learn the thing. Just don't let them go on for like 15 minutes. You've got quite a short amount of time for this connect. Then there's the exercise, and you might need to prepare so that everyone can very quickly and easily get going with this. So make sure the code is all prepared and easy for people to get hold of. You can do this in pairs, that's usually my choice, but if your team is quite inexperienced with mocks, you might find it easier to have everyone together in the same group and work ensemble style. Just make sure that whoever has the keyboard doesn't kind of go off on their own, and that everyone in the group is talking and understands the code that's being written. But that is a good choice when not everyone in the group is very confident with using mocks. And mocking tools, because that's the other part. If you're going to get to the part with the mocking framework, you need to be a bit more prepared there. Have chosen a good framework and make sure it's all installed and everyone can get it. And if you're using C# like I was, I could recommend Mock, MOQ, very popular framework for .NET. So that might be a good choice to try if you haven't got any better ideas. And then there's the discussion. And at this point, it's probably good if you have done a bit of preparation and know what the test should look like with your chosen mocking framework. So I've put on the screen here what I came up with when I did this with MOQ. On the left is the code basically that I produced in the demo, and on the right is the code I produced using MOQ. And as you can see, there's less code when I'm using the framework, but it might not actually be any easier to work with. So these are the kind of questions I want you to be asking. How much code is there to read when the test fails? Is it clear what the mocking framework is doing? Do you understand the failure that you get? And is it really clear what you should be fixing? Because I don't know about you, but in your mocking framework, but I felt that actually my hand-coded mock was standing up pretty well against these questions and wasn't actually much more work to do than the mocking framework. But you might disagree, and your team might come up with a different strategy. And part of the point of this is you should have a chance to discuss that. So while you're hosting this discussion, just a few things to keep in mind. Any test that you're discussing must expose the bug. So there's no point in discussing tests that don't fail with any useful error message. There might be people in your team who are a bit quieter, a bit less inclined to talk, but have valuable things to say, and do encourage them. And also try and stay on topic. You haven't got very long for this discussion, and try and keep it to, well, should we be using mocks? What benefits do they give us? What do we need to learn? What do we need to improve for our team? And then there's the conclusions. This is really quite short. It's just a chance for everyone to think for a bit and work out what to take with them. So don't say too much here. Get people to think. It's for them, not for you. And if they don't write anything, that's fine if they've had a few minutes to think. But try and just be encouraging and friendly and get people to come away from the session with a positive opinion of how it's gone and what they've learnt from it. I hope that you feel able to try this session out with your team now. It is so much more fun to do this in a group. And using test doubles effectively is an important aspect of designing good unit tests. If you do give this session a go, please leave me a comment about how it goes. I would love to hear from you.